Hi, today we will see how the electrical networks are solved when they contain shorted paths in them. Let us see with the example. When this is the example given and question asked is find the total current I. If you look at the network, it is a bit complex to say these two resistances are in series or in parallel. So what we have to do, we have to redraw the circuit. And before redrawing the circuit, we will mark letters in the original circuit and then we will redraw it. Now if you see the circuit or the network, you will find A and D, between A and D there is a short path. Between B and C there is a short path. So whenever there is a short path in the network, you can make that short path as a one common point. What I mean to say is this. While redrawing, what I am doing, A and D, they are shorted, so one common point is taken. Similarly, B and C, they are shorted, so one common point is taken. Now our major job is over. Now only thing remaining is you just connect the components of the original network between these 2 points. See, 8 ohms is connected between A and B, so this is 8 connected between A and B. 12 is connected between C and D, so this is again same point C and D, that is 12 ohms. And now battery is connected between A and C, that battery is connected between A and C, that is equal to 24 volt. Now if you compare both the networks, you will definitely find the diagram which is redrawn. It is simple to understand, and here we can definitely say 12 and 8 they are in parallel. So I can calculate total resistance as 12 parallel 8, and that comes to be 4.8 ohms. Now I want to calculate I, so I is equal to V upon RT. So V is how much? 24. 24 divided by RT is how much? 4.8. My answer comes to be 5 amperes. So whenever there is a short path in the network, follow these steps, your network becomes easy to analyze. Take one more example in this case. Now again I want to calculate the total current I. So I will mark the letters A, B, C and D. A and D are shorted, B and C are shorted, so I will take common point. So A and D, one common point, B and C, one common point, and I will now go on connecting the components in these points. 8 ohm is between A and B, 6 ohm is between B and D, 12 ohm is between C and D, and battery is connected between A and C. So from this diagram, again it is very easy to understand that 12, 8 and 6 they are in parallel. So if I calculate RT, that is 12 parallel 8 parallel 6, if I calculate the answer, that comes to be 2.66 ohms. So I can get I easily, that is V by RT, that is 24 divided by 2.66, my answer comes to be 9 ampere. So take one more example of this type, that is this one. Now you got an idea what we are going to do. So again I will mark the points A, B, C and D. There are two shorted paths, A and D, that is common point, B and C, that is again one more common point, and we are going to connect components between these. Between A and B 8, B and D 6, C and D 12, and A and C 4, and battery is connected between A and C, that is 24 volts. So again we can see very easily 4 resistors are in parallel, so I can calculate RT. My answer, you can use your formula, that is 1 by 12 plus 1 by 6 plus 1 by 8 plus 1 by 4 is equal to 1 by RT. So you will get RT is equal to 1.6 ohms and from that you can get the current as V by RT, that is 24 divided by 1.6, that comes to be 15 ampere. So whenever there are shorted paths, you can follow these steps. If you see this circuit now, same way we can go. This is A, this is B, this is C, this is D. Now B and C is common point. Only one common point is there. This is my A, this is my D. This is common point D. So between A and B there is 2 ohm. A and B there is 2 ohms. A and C there is 2 ohms. Here 2 ohms between B and D. Here 2 ohms between C and D. And now between these 2 points our battery is there, that is equal to 2 volts. So we can get 2 parallel 2, here again 2 parallel 2. So finally I am getting circuit as 2 volt, 1 and 1. So total resistance becomes 2 ohms. So I can get I is equal to 2 volt divided by 2 ohms, that is equal to 1. So whenever there is a short path in the network, you make a common point for that, redraw the circuit, and it will be easy for you to calculate the total resistance. This concept or this procedure you can follow for your bigger networks also. There also it becomes very easy to calculate total resistance and total current. So thank you for listening and watching my video. If you are satisfied, please do like, share and subscribe to my channel. Thank you.